So hey everyone, welcome back to my channel. This is Lakshya here. So today we're gonna start with our lead code question number 79, which says word search. Let's first read what this question says. It says given an m cross n grid of characters, board and a string word. Return true if word exists in the grid. Okay. The word can be constructed from letters of consequentially sorry adjacent cells where adjacent cells are horizontally or vertically neighboring. The same letter cell may not be used more than once. Okay, so what we have to do in this question, so in this question we will be given a matrix, or you can say a grid of alphabets, and we will be given a string of word. Okay, and we have to create that string. We have to basically find that string in a grid like this, that this or this, that how can we form, like example here we can see that we got this, but there is one edge case. Sorry, that's not an edge case, there is a condition basically that we can't take an alphabet more than once. Okay, like you can't do the like this, that once you got there and then you again use this word. Okay, so let's take this example only to understand it more clearly. So here we have been given a grid, or you can say a matrix like this. Okay, and what are the alphabets here? A, B, C, E, S, F, C, S, and A, D, E, E. Okay, cool. And we have given a string, that is A, B, C, C, E, D. Okay, so we will create a pointer index which will be at the here, and we will start traversing our matrix. Okay, we will start our matrix traversing our matrix like this only, and we will check, sorry, like this first, like this, then this, then this, and we will start our traversal. We will start checking our string only when we first find our first index. Okay, so at starting first of all we will check this, so we can see that we got this. Okay, oh, wait a second, we will check that if our first alphabet of our board is matches to our index or not. If it matches, okay, then we will again call a function and our index moves further. We call a function for our next index that now find that word the word pointing to our index, that here is B, does it present in a board, and you can only search for like one direction, one block up, one block left, one block down, and one block right only. Okay, so whenever we try to check, like when we check here, we can see that our row is, it is getting out of bound, so we will directly return from here. Okay, we will not check this condition. When we will check here, we will again see that it is out of bound, so we will again return from here. So that means we have to create some base cases here. Okay, for the out of bound condition, and what can be another condition, we will tell you later what will be our another base case. Okay, then it again checks here, and we can see that it doesn't matches our index, so that means it again returns. Then it again checks here and it matches. Okay, if it matches, then again we call the same function for this index, and then now our index is points here, so now it checks for left, right, and all directions. Okay, so it again finds this, then this function calls, then it finds this, then this, then this, and at last we got a string and it start returning true, 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 and at last we returns true. Okay. So what's the another base case? Then another case will be when we traverse an index like this. Now index here, index here, index here. So now we, and then our index when moves this here, like when we reach here, then it again calls for the next index. So that means our index pointing here. Then another base case will be whenever our index is becomes equals to a size of our string. That means our size, sorry, size of our word. That means that we have traversed all our strings successfully and we can simply return true from here. Okay, so that this will be another case, that this will be another base case, and the first base case was that if our value becomes out of bound, we will simply return back. Okay, these two are the base case that we have to keep in our mind. Okay, so now let's write down the pseudocode and then we will create a recursion tree to actually see the workflow of this problem. Okay, let's write down here. So at first, this is our main function. Okay, Here we will be given, let's write here only, our board is our basically our matrix, and our string word that we have to check in our board. Okay, so first of all we will find our size. It m becomes board dot size, that means our rows. And similarly we will find our columns. Is the board 0 dot size, this will be our columns. Okay, cool. After that, what we will do, we will start our for loop that will be from I equals to 0 till how much, m minus 1, and other loop that will be same from 0 to n minus 1, and we will call our function that if, let's name the function as find. If we call our find function, we will pass our indices of our grid, basically like this was our grid now. So here first index will be I equals to 0, j equals to 0, means this, wait a second, this. Okay, and another index as 0, because at starting we know that our word, we will find our words first letter, like we have to find this, so we will pass this our 0th index first. From here we are starting, and obviously our board and our word. Okay, and if we find the first letter, then we will start a traversal on that function only another. That means if we find a first letter, we will simply return our true. Okay, but if we didn't find, we will return false. Okay, this is our basically our function. Okay, I will explain this you now how this actually works, why we are returning directly true after finding first letter. Because when the find function calls, let's write down the find function here. It is having our same index. This is our index and our board and our word. Okay, so when it calls, so first of all what it will check, remember what's our base case, that if our index is becomes equals to our word dot size, this means that we have traversed all our values successfully, and we will simply return true. Okay, and then what's another base case, that if our I is smaller than 0, okay, or our j is smaller than 0, or our I is greater than equals to m, or our j is greater than equals to n. These all condition refers out of bound. And another condition, sorry, and another condition is if our board value, that is ij, this was the value that we were sending, these were the indexes, is not equals to, is not equals to our word index. That means that for that word we were checking, if they are not equal, that means that this doesn't matches, so we have to return false from here, that we can't move further, we simply return back. Okay, but if these are not the cases, that definitely means that the word we were searching, it's definitely in that grid, means we are pointing to a right word. So that means then what we will do, first of all we will create a temp, and we will store that word. Okay, why we store that word, because we don't, I will tell you. Okay, first of all we will store that word. Okay, that is board of I of j, and then what we will do, we will change that word as another character, like dollar, suppose. Okay, because why we are doing this, because we don't want to go back to that word. Suppose there was like this, a string was like this, a b a c, and it was like this something. So when we move from a to b, then it will again checks for a, because now b wants another string is a, then it can again move to here. That means it can use the same string same character two times. So to avoid that misconception, we are using, we are, whenever we will use a character, we will convert it to a dollar, so that we can't use that once again. Okay, so after converting it, now we will check for the next integer. That means we will call another function like if, we'll call find, if or find, let's remove it. And what we will do, we will now check for the next row, I plus 1 comma j and our index becomes +1 because now we are searching the next character of our word string. And then same our board and our word. Okay, this will search what? This will check for this index. Okay, when we call from here it will check this index. Okay. What's another condition? Now we will, there will be another also, that now check for I-1 j, and the same values are will be same. This means that this will check for I-1 means a row above it, that if that the it means that if the next character is present above or below, then similarly it will check left and right also. Like this, find I means the row will be same but the columns will be different. It means a column back and the same characters. It will check that if our string, if our character is present here or not. Okay, and also, and then what's another thing, it will check like this also, that if like this, now it will check our right side also, that if our character is present here. So if we find a character among this, that any of this will be true, this simply returns our true. This will return our true. But if we have checked in all the directions, that here we didn't find it, that means that this string is not messable from this way, so we will simply return false. But before returning, first of all we will again change our value. Means you can see here now that we have changed our board to dollar, so we will again change it to the original value that we have stored in temp. That's why we have created temp. Okay, now you understand why we created temp before, because we want to store, recover our value that we have changed. Okay, so what we will do, we will change our value like this, that now we will store our value back, that board of I of j will become temp, like this. Okay, and at last return false because we didn't find the next index, that's why. So this is the pseudocode and this is how we're gonna approach this problem. Let's also try to make our recursion tree. First of all, let's create our matrix A B C E SFCS SFCS ADE. Okay, and our word is, let's take our word is A B C C D E. So at starting it will call a function for A. Okay, because it is pointing like this. Cool. So when it calls for A, then what will happen? The A will call for E, means the A will checks. There will be 4 calls, okay, from A. One for the up, one for down, one for left, and one for right. And this all calls will be passed with the index +1 because now we are finding for another index. Okay, that means now what we are finding B. That means index +1. So he will check for here, that no, first it will check for here, then it checks for here, then it checks for here, it checks for here. But we can see that he finds here, because when it goes for up it's out of bound, it finds for down it's doesn't matches, then it finds for right, it all left, sorry, it lefts, then again it goes out of bound, but when it goes right it found. Okay, so now what, we have got our B. Now again B will check for 4 directions, like this, up, down, left, and right. But on left it will not get it because A is already converted to dollar, and also dollar is not equals to what we are finding, because we are finding now C, because now our index is moved to C. Checks, it doesn't get, but at one direction, that is right, it finds. Okay, it finds its value. On left it doesn't get it, so on up it doesn't get, on down it doesn't matches, on right it got its string, sorry, its getter. So okay, so now this again calls for it because this becomes true. Now it again checks like this, then it finds another C, that we want, then it again checks, it finds E, then again checks and finds D. Okay, so now sorry, there's a mistake. Found D first. Is also this D and E. So it found D, then D found E. Okay, so after finding D, now I is here. Okay, so when it find D, now E, it again calls for index plus 1. That means now search for the next index. So when it goes the next index, it calls this base case that we have wrote, that here, that if index becomes this, it returns true. So when it checks that now our index has reached to the size of our string, that means we have checked for all the strings successfully, so it returns true. Okay, so when it returns true, we know now that there were 4 cases. We wrote here like this, that there were 4 cases, and if any of them, because we have used or, that's why we have used or, that if any of them becomes true, that returns true. So that's why from here also it returns true. Then similarly there was also here 4 cases, so one becomes true, then it again returns true, so it returns true from here. Similarly. Okay, so at last what we have got true, this, that was our main function, we got true from here. Okay, we find a true, and that's why it returns directly true, because it have, this function have already checked for the next values, means the next characters of our string. That's why it returns true from here. And if this returns false, that means that all the values were false in the process. That's why it returns false, and at last it returns false. Okay, so that's it. Let's see our code here, but that's a pseudocode, and you can perfectly try this pseudocode and just modify a few changes. You will definitely get your answer. So this was our code. Similarly, like we said, that first of all we'll find our rows, then columns, then we will run a for loop for each match with our first index, and if it matches, then it calls for the next, it runs to this function to check. Okay, also I forgot to mention that we have to again find our sizes like this to check for the out of bound condition now. Okay, then checks for the condition also if the string matches or not, means if the character matches or not, sorry. So if not matches, return false. If matches, that means that we find out our word, and now we have to check for the next one. So before checking for next one, we store it in temp and modify it to dollar. Then it again checks like this and returns true. And at last, if it hasn't returns true, that means this condition failed. And that means we didn't found our character in the next index. So we will definitely change our board and that character back to our value that we have changed to dollar. We again change it back and return false. So that's it. This was a code, pretty simple I guess. Now let's discuss the time complexity. Okay, so the time complexity will be big O of m cross n. Because of this, the two for loops which runs for m and this runs for n, that's why m cross n for these two nested loop. And what's another? C. Another is for recursion call, that we are calling for the find function. No? For that, this will be a time complexity, because each value are having 4 cases like this. We have discussed each is having 4 cases, and 3 to power l minus 1. Why so? Because we know that once we traverse this, we are changing it to dollar. That's why there will be not 4, that will be 3 cases. That's why we have used this and this. So we can write in simple language like this: big O of m cross n cross 3 to the power l minus 1. L is a, what is L? L is the length of a word. Okay, this will be a time complexity. And space complexity is simple. We are not using any external space, that's why there will be no anything, but there will be big of L. L is a length of our word, because this will be the number of recursion call we are gonna make, because we know now that we have to check for the length of the word, that is like this: A, B, C, D, E. So we have to go for A, then B, then C, then D. So our recursion call will be the length of our word only. So that's it. This is a time complexity. This is a space complexity. So thanks for watching. Stay tuned. Bye bye.